Hello. Hello. Hello, my dear friends. I hope the voice and the video is clear. If anyone in the live wants, they can. If anyone in the live, they can text whether the video and the audio is clear. Abhinay, good evening. Good evening, Abhinay. Good evening. Video and the audio is clear, Abhinay? Chal. Now, anyone in the live, they can say hi if you are in the live. Oh, okay, fine, fine, fine. Done, done. Done. Now, in the last class, we have studied now what are the basics we need to start the alloalkane haloarenes. Clear? Now, alloalkanes, haloarenes already what are the basics to start we have studied. That is, now what are the solvents we have required to know, which will comes under the polar protic and the polar aprotic. Then when sometimes the nucleophile will act as a base and sometimes the base will act as a nucleophile. Clear? Now in that cases, now when to, hi Praneeth, hi. Now when to act as the electrophile, sorry, when to act as the nucleophile and when to act as the base also I explained very clearly. Now in the last class we have explained, I was explained very clearly about the how the SN1 reaction will be happened. Just once I will recap that SN1 reaction and followed by today's class. Now today's class we are having the which one? SN2, E1, E2, E1CB and SNI, then followed by the n number of questions from the normal level, mains level and the advanced level, as well as if any NEET students are there, for them NEET level also. Okay, listen to the class carefully. If you are, so when I was asking the question, you know, right? If you know the answer, try to say the answer. If not, just give the what question mark, so that we will save our time. In the less time we can cover the more number of content. Okay, done. Is it clear? Is it clear? Right. Now first let me reduce my, right. Yes sir, done. Here, no. In the last class we have seen the which one? SN1 reaction. Now in the SN1 reaction we know, should I start with alcohols, phenols, ether directly after GOC or after Abhinay? Once GOC completed, start with the haloalkanes, haloarenes. Okay, start with the haloalkanes and the haloarenes. Don't go with the alcohols, phenols and ethers. Sequence you have to follow. Sequence gellu. GOC, hydrocarbons, haloalkane, haloarenes, alcohols, phenols, ethers, next carbonyl compounds, like that. Right. Now, what is the SN1 reaction? Now, in the SN1 reaction, if you take the 3-degree alkali halide upon aqueous Ag2O, now aqueous KOH or the moist Ag2O, if you have take, then what it will happen? Now, the aqueous medium means H2O. In that H2O, what it will happen? Now, it will form whatever the bond it has formed. Okay, whatever the bond it has formed, here this halogen, it will form the bond with the hydrogen in this H2O. Clear? Now then what it will happen? It will get the bond energy. Due to that bond energy, it will be eliminated as a leaving group. It will be eliminated. When as a leaving group it has eliminated, here it will get the carbocation. After getting the carbocation, we know this carbocation is sp2 hybridized. When this carbocation is sp2 hybridized, now we can get the product from the which one? One is a retention. Retention means from where the nucleophile has been left, that side if the from where the leaving group has been left, that side if the nucleophile is added, that we call it as a retention. Clear? Now opposite side if it is added, that we call it as a inversion, that we know. And 50% retention and the 50% inversion, we call it as a racemic mixture. Done. Next, what are the key points that we required for the SN1 reaction? That is 3-degree alkali halide or alcohols readily undergoes SN1 reaction. Non-concerted intermediate is present. What is the intermediate that is present? That is carbocation is the intermediate. It is present in the SN1 reaction. Done. Next, here the next very important point, in the SN1 rate of the reaction depend upon the stability of the carbocation, not on the incoming nucleophile. Clear? Now how the potential energy, potential energy and the reaction progress, if the energy profile diagram, if they ask, yesterday I explained you right clearly. If suppose if here if any some mesh sheet is there and if you add the sand to it, ఏమవుతుంది? ఆ మెష్ లో నుంచి శాండ్ ఒక్కసారి ఆ మెష్ లో నుంచి శాండ్ కిందికి వచ్చినప్పుడు వెరీ ఫాస్ట్లీ వెళ్ళిపోతుంది కదా. సేమ్ థింగ్ ద రియాక్షన్ టు బి హ్యాపెన్ first for the energy profile diagram. Now the formation of the carbocation is a slow step. Once the carbocation it has formed, now the product will be formed very fastly. This is about the energy profile diagram of the SN1 reaction. I explained very clearly. Then we have did the some questions based on that one. Now yesterday we have ended the class here. Now can anyone say the among the in these two SN1 reaction will be happen very fastly? What is the order? SN1 reaction will happen in which of the following very fastly? SN1 reaction will be happen very fastly in which of the following? SN1 reaction will be happen very fastly in which of the following? 312. 312 is of lower to higher, higher to lower. Pranit is from lower to higher or higher to lower? Lower to higher or higher to lower? So 213. 213 because electron releasing group, right? High to low. The 213 because what? Carbocation stability you have to cross check. Then next one, one question I will ask you. Now you have to say me here. Here the Br they have given. Here the oxygen they have given. Here it is a Br. Now here it is a Br. Now here it is a Br.